Hello, everybody. This is Unit 1. This is Section 1.1. So this is the beginnings of astronomy. So we're going to start off with a quick, what is astronomy? It is a type of natural science. It is something that studies everything beyond the Earth's atmosphere. So once you get up into space, you are talking about astronomy. It relies upon the physical sciences of chemistry and physics, so it weighs heavily on those. And please do not confuse it with astrology. Astronomy is not astrology. So to look at a little bit of kind of a brief history, the timeline, astronomy comes from the Greek word astronomos, meaning star arranging. The practice of observing, measuring, and recording celestial motion predates the Greeks. So we're going to go back beyond where the Greeks were. The Greeks are, several hundred years BC. We're going to go back way, way further. The following slides will take you through various moments in history, and it'll go all the way up to the Renaissance. The Renaissance happened in about the 1500s. So we're going back to 32,500 years ago. Actually, about 34,500 years ago, because this is BCE, so before the Common Era. This would be the Upper Paleolithic period, a long time ago. Humans were engraving in animal bones, and they think that these represent the moon phases, and that they were showing, like, here's the full moon, and then it got a little smaller, and then it got bigger and bigger. They carved the constellation of Orion into a mammoth tusk. So pretty cool. They were already taking note of what was going on. So the tusk is pictured there on the side, and those are celestial motions that they think they are engraving. Now we get up to about 10,000 BCE, so about 12,000 years ago. They started to realize that they could predict when the seasons were coming based on where the stars were in the sky. So they were starting to make the connection between star positioning and season of the year. They were used for measuring time and direction. And it helped bring about the agricultural revolution because they kind of knew when they should start planting based on where the stars were. So the Mesopotamians, about, we'll say up to 5,000 years ago, started creating multiple constellations, and they started to mark the path of the sun, the moon, and the planets. They were starting to kind of take notice of these paths that things took through the sky. The Sumerians created star catalogs. So they started to write down these stars that they saw, where they were positioned, and they kind of started to name them. Stonehenge was built in England about 2500 BCE, and that marks the solstices. The solstice is the time of the year where the summer solstice is the longest day, the winter solstice is the shortest day. The Chinese record the first solar eclipse in 2137 BCE, and the Babylonians recorded positions of planets and solar eclipses. Now, they didn't name anything yet, they didn't name the planets, but they started to realize that those things were up there. Egyptians started using sundials to measure time. So they were actually using the angle of the sun based on its position in the sky to figure out what time of the day it was. So now we're getting a little bit closer, 500, 800 BCE, so not too long ago. Indian astronomers start creating the heliocentric model. That means that the sun is in the middle, and it's the middle sphere with the Earth kind of in an outer sphere, which is interesting because they kind of go from that to a different line of thinking later. Mayan astronomers discover the moon cycle, create an almanac, and table the movements of the sun, moon, and planets. So they're starting to actually catalog these movements through the sky. Greek astronomers predict the first solar eclipse. They actually have an idea of when the moon is going to pass in between the sun and the earth, and it's going to create an eclipse. So now we're only several hundred years BC. This is when the Greeks are really starting to kick things into motion. Anaxagoras suggests stars are like our sun, and he correctly explains how eclipses work, and he attempts to identify meteors and realizes that the moon does not create its own sunlight, it's actually reflected light from the sun. Babylonians divide the heavens into 12 segments using the zodiac, and Plato founds the Platonic Academy, promoting the idea of geocentrism. So now they're starting to think, oh, the Earth is in the middle, and the sun goes around the Earth, and the planets go around the Earth. We find out eventually that's not right, but it was interesting at the time. Aristarchus also proposed the heliocentric model back in about 270 BC. The Chinese astronomers first record Halley's Comet. Halley's Comet comes around once every 76 years or so, and that's the first time that it was recorded. The Antikythera mechanism is created. That's the thing you see in the background. It's all rusted and corroded. But what they think it could do is it could track star and planet positions and eclipses by having a series of very intricate little dials and gears that they could adjust and move. Chinese astronomers cataloged over 800 stars, 120 constellations, and they started to identify sunspots on the sun. That's tricky because we can't really look at the sun that long. It's a bad idea. And we'll talk about what sunspots are later. Okay, now we're getting into a little bit more modern times. So we're into the Common Era, which is after, this is AD. You may know it as AD. It's also called CE, Common Era. Ptolemy endorses the geocentric model. So this is another Greek, and it will be called the Ptolemaic model. It remains popular for 1,400 years. So it took off and it held true for a long time. At least they thought it was true. And that's a picture of it on the right, where the Earth is in the middle and everything is going around the Earth. Hindu astronomers calculate a year as 365.256 blah, blah, blah days. Oops, days. D-A-Y-S. I'll make that correction. It was 1.4 seconds off from the modern value. That's amazing. Hindu astronomers were only 1.4 seconds off the value of a year back about 1,700 years ago. Indian astronomers proposed gravity, elliptical orbits, spinning planets, and that the sun revolves around the Earth back in about 500 CE, so 499. Now we're getting a little bit more up to date. Indian astronomers further refine gravity. They consider it a force of attraction, but they don't really name it yet. There's somebody else who gets the fame for that. And they calculate motions of planets. Muslim astronomers complete work containing movements for planets of the sun. So Muslim scientists were working very hard at the same time. A lot of things in math and astronomy can be attributed to Muslims. A lot of things that started with AL. Muslim astronomers refine the Ptolemaic system, and they calculate the circumference of the Earth. So they knew that the Earth was round way back then. This wasn't something that was, that was more modern. They knew that the Earth was round, and they knew that it was like a globe. But they even were calculating how big it was. The oldest surviving astrolabe was constructed by a Muslim astronomer back in 930 CE. An astrolabe helps sailors get across the oceans and helps them measure where the stars are. Okay, now we're getting up to the most recent time. Chinese and Native Americans note a sudden bright star, supernova. Supernova is an exploding star. That was around 1054. Indian and Islamic astronomy introduced to Europeans in about 1126. So that's where you are starting to see these different nations were starting, or I shouldn't say nations, but these different groups of people were starting to teach each other what they knew. Indian astronomers calculate more about the planets and find problems with the Ptolemaic system. So they're starting to think, hey, this whole Earth-centered thing isn't really working. Muslim astronomers create an early alternative to geocentrism way back in 1190 CE. And Muslim astronomers further cast out on geocentrism and go back to the idea of heliocentrism, which would be where the sun is in the middle and everything orbits the sun. All right, so I do have one little question. Were you aware that so much of the world was working on astronomy in relative seclusion? And what I mean by that is you had groups of people working all over the place. You had Hindu people, you had Chinese people, you had Greek, you had Muslim. So they were working in seclusion in these different parts of the world, yet they were all finding the same things. That's how science works. That, you can bring this information together and you realize that the information is the same and now you have to start working with it. So that's the end for this one.